through the potential divider, something that a lot of students find quite a challenge, but hopefully by the end of this short PowerPoint you will get the basic idea. When I ask you to pause the video that you're going to listen back, that's just so you can do a task, but mainly your task at the end will be just to submit some potential divider questions via Teams right at the end. So here goes. If we have a supply, this could be a battery or a power supply, that potential difference that supply provides, will be shared between the two resistors in this case. And if we put a voltmeter across the two of these resistors, one will show differently to the other if these are different resistors. If they're the same resistor, remember, that V1 and V2 would actually read the same. We're considering if they are different, and each of these here could be a supply output to another circuit. So that's the aim of the potential divider, to get an output that potentially could vary. If this was a variable resistor or an LDR or a thermistor, this resistance changing would change this output here as well. So that's basically the idea of why we have a potential divider. So the source potential difference is shared across these two resistors. Now, to find the total resistance of these two, just like we did when we did Ohm's law, the total resistance of this circuit is R1 plus R2, which you can see here. And to find, using Ohm's law, the current through that circuit would be VO divided by the total resistance, which would be R1 plus R2. So hopefully that makes sense. Now, for a fixed potential difference then, if we look here, the current through this circuit, IO, so that's the total current going through the circuit, is the source potential difference, in this case is VO, divided by the total resistance, which is R1 plus R2. So V1, consequently then, would be the total current going through the circuit times R1, okay? So then if we consider replacing IO here with this V over R1 plus R2, that gives us this, VO over R1 divided by R1 plus R2. So what basically that's saying is the potential difference across R1 is a proportion of the total potential difference of this. So this is the total supply. So it's how much of the total supply here is across there. Well, that's found by the ratio of R1 out of the total resistance, which is this here. So you could replace R1 plus R2 by RT, the total resistance of these two. Okay, so it's how much of this out of these two does this get a share? Does it get a share of? Okay, so we've got some examples to show you. So the potential difference across each resistor is a proportion of the source PD, and the resistance of that is a proportion of the total resistance. So they're interchangeable with those two. So an example here would be V1 now is the source PD, VO, it's 5/15ths of the source PD would be across there, or 10/15ths of the source PD would be across here. So it's literally just a ratio of the total resistance and the actual V1 resistor's resistance. Okay, hoping this makes sense. Okay, so just have a little think, just pause it and have a little think. Okay, so just to recap, V1 is 5/15ths of the total supply potential difference, and V2 is 10/15ths of the source potential difference. Okay, moving on. So this gives us this here, this ratio. So V1 over V2 equals R1 over R2. So if you know V2, R1, and R2, you can find out V1, and consequently you can find any of these by rearranging. Okay. So let's follow this through. Now, just something I want you to be aware of. Resistors usually come in kilo ohms. So remember, you need to convert that first. So we need to deal in this. It's not strictly, because it is a ratio, you don't have to do that. But remember, I have actually encouraged you to convert everything right from the get-go. So remember, always convert it. Okay. So if we look at the formula here, the voltage, so output voltage across V1 here, this is EO, the supply potential difference. Much of this potential difference is shared between these two. So in this case, we've got 4.5 volts, and it's 1,000 divided by 1,000 plus 5,000. So this out of the total is it got of this. Okay, so it's just like we've just done. In this case, it's 0.75 volts. So just stop it, have a little think through it, and then we'll move on. Okay. So here we've got example again. Here we've converted to ohms. We've got our potential difference. Here is 4.5 volts, which is of our source. And we've got 4.5 here, time it's 5 out of 1,500. So it's 5,000 out of 1,500 gives us 3.75 volts. Okay, moving on. Now, sometimes they're quite crafty and they can try and throw you out by giving you a parallel circuit here. So remember when we worked out parallel resistors in parallel, which is here, R2 is 1 over that divided plus 1 over that. So we did 1 over R2 equals 1 over 5,000 plus 1 over 5,000, which would give us a resistance of 2,500 ohms. So just be careful. If you get that, all you need to do is work out the total resistance of that. The total resistance of the circuit would be this, then plus the total resistance of these two in parallel. And then it's just the same. Here we've got our V2, the total resistance of this, which we've called R2 here, divided by the total resistance of the circuit, multiplied by the potential difference of the source, which will give us 3.2 volts. So again, stop it and have a look. Next one. Now, sometimes you might be asked to find the current in this circuit. And again, it's just like you would do it in a normal Ohm's law circuit. So we've got a total VO in this case here, which is 6, divided by the total current of 0.5 amps. Another example, here we've got our circuit. This time I want to find V1. So it's what proportion of the voltage, high voltage, is this getting? So it's our 6, which is our VO, times 8 divided by 8 plus 4. So this is the total resistance. So it's 8/12 of 6, which gives us 4 volts. Right, I'm really hoping that's made sense. Our final example, you can just have a look through yourselves, but it's the same idea, just looking at for V2. Just stop it and have a quick look. And this is an example when you're not given the source PD, you just know the two outputs and the two resistors, or one of the resistors. So you've got the 3 out of these quantities, but you don't know the 4th. So you're just asked to find the 4th, and you just have to rearrange this. So remember, if you want V1, V2 can go up here. So then it would be R1, V2 over R2. If you're after R2, for example, R1 would be V1, R2 over V2, and so on. So just have a little consideration for yourselves and just rearrange this for each of the 4 quantities. So you're happy with doing that. And finally, guys, just so I know you understand that, On Teams, I've given you a worksheet. Complete the worksheet. Make sure you show all your working, please, because some of you still aren't doing that. Show all your working and then submit it back to me on Teams for me to check. So thank you very much, guys, and good luck.